Hello everyone and welcome to the pre-mock review video for paper 2. This paper covers the mathematics and non-verbal reasoning sections. As before, just quickly look through the instructions. If you've watched the paper 1 video, you'll know, really important that when we're working, obviously we stop at the end of each section, just something to be aware of for next time you do the exam. When you're marking, we want it to be a firm horizontal line, firm enough that it can be clearly seen, and it should really sort of cover the entirety of the box, but not so firm that you can't rub it out, because of course if you make a mistake you need to rub the answer out. So there's a bit of a balance, and I would say generally speaking, if you could see it if someone's behind your shoulder could comfortably see the answer, that's about firm enough, but equally not so firm that you can't rub it out. Really important that you make sure you keep your place on the answer sheet, don't get muddled, and one of the main things that can add to that muddling is if you do accidentally end up forgetting, for example, to do the practice questions, because then you might accidentally write the real answer in the practice question slot. So just be really clear that every time you're checking, question 1 goes in question 1. It's also perhaps worth noting, and especially for this maths paper where you'll be doing lots of work out on the actual question booklet itself, I would recommend answering both on the booklet and on the answer sheet, and that way you've got a little bit of a backup. So if anything did go wrong, you can check back to what your answers on the question paper are, and then fill them in. And they'll only be sort of quickly circling or underlining them, and it shouldn't add too much time, and it just gives you that confidence that if anything did go right, you could check. Obviously make sure you work as fast as you can. There's a lot of questions in the maths, and so you may not necessarily get all of them, so you then want to make sure that you're skipping and doing only the easiest. And so one of the big things is obviously starring a question that you're not sure about, moving on, and then coming back later is a really, really important skill, because you want to make sure you're getting access to the easy questions. And with maths, everyone will have different strengths and weaknesses, different questions that for them make sense, and others that are a bit harder, and it's not guaranteed that you will find questions later in the paper easier or harder. They can slightly scale with difficulty, they do tend to get a little bit harder towards the end, but there's no reason why the ones at the end you might find much easier, because it's something that you've either done at school or that you just really got. And so it's really important that you make sure that at the very least you've looked at all the questions in the paper, so you can sort of have the best chance of possibly doing the questions and doing really well. Any working can be done in the booklet, but of course not on the answer sheet. The answer sheet should be kept pristine. And finally, if you can't do a question, just skip it, move on, and at the very end, really important, just have a guess. Anything that's blank is automatically wrong, whereas if you have a guess, you've at least got a chance of getting the answer. So as before, you had the practice questions, and I've got the answers for these here just so you can check them. So for the first one it was B. It's just a multiplication. A few ways of doing it. You could split the multiplication up into multiple steps. That's probably the most universal, where you just do 10 times 16 and 3 times 16 and add the results together. But there's lots of methods, and again, I always say for multiplication, whichever method works best for you is the approach I would recommend taking. For question 2, or practice question 2, again, you just have to make sure that you're being methodical. £20 take away 6, and then you need to do the 4 lots of 3, which is 12, taking away as well, leaving you with £2, and that's going to be 50p divided by, or 50p per packet, £2, so by the 4 crisps is going to be 50p each. And finally, for the angle A, it's quite a good question as well. It requires you to know that angles about a circle are 360, therefore this missing chunk must be 60, and it requires you to know that angles in a triangle add up to 180, so 180 minus the 60 you've worked out, minus the 55 in the corner, leaves you with this top corner here of 65. So they're actually some quite good meaty practice questions, and well worth having a look at and just reading through and make sure you understand the explanations. We're now going to jump into it, and we're just going to go through all the questions. Again, as I say, when you're doing this for real, skipping questions is obviously important, but for the purposes of us going through it together now, I am going to make sure that we just do it together. We run through all the questions. So off we go. Number 1. What is 32 minus 9? So obviously you could write this out as a subtraction, but this is something we'd hope most people will be able to do in their heads. And of course the answer is 23. So there's your answer C to that first question there. Number 2. I drew a pictogram to reflect the number of stickers 4 friends own. Each sticker is worth 2. That's what this little triangle means. So each triangle is worth 2 stickers. So how many do they own in total? That's 2, 2, 2, 2, which is 8. 2 plus 2, which is 4. 2 plus 2 plus half, which actually means then we have 5. 2 plus 2, which is 2 plus 2 plus 2, which is 6. Plus the 1 is 7. So now we know we've got all the people here. And in terms of adding these, my recommend is always trying to add up to 10s and 20s. So I've spotted, I think, here that if I do, for example, 8 plus 7 is 15, plus 5 is 20, and that makes it easy to add the plus 4. So mentally I know the answer is 24. Calculate 3/5 plus 2/15. The rules for adding fractions are the bases must be the same. So if this one was already 15, I'm going to turn this left fraction also being out of 15. And the way I do that is I've multiplied the 5 by 3 to make it 15. So I've got to do the same thing to the top. That means it's going to be 9/15. Obviously, this 2/15 is still 2/15. And so my final answer is going to be 11/15. And that's really important. Once you've got the denominators the same, the numerators can just be added, and that makes it really easy. So once the bottoms are the same, you can just add the top numbers, and that's how fractions work, which is nice and simple. What is the perimeter of the triangle? Well, perimeter means the outside, so a good little trick for the outside is just first off to label everything, making sure that you realise that, of course, there are 4 sides. And there's a few ways of doing this. You can just add them all up. You can actually do 24 plus 8, which is 32, and then 32 doubled, because it's going to be the same thing, giving you an answer of 64, so that works as well, or just adding them up works as well. On to number 5. What is the area of a square with a width of 9 centimeters? Well, if I do myself a quick little sketch, the nice thing about squares is all the sides are the same. So if I know this is 9 centimeters, this other side must be 9 centimeters as well, because they're all the same. And then we need to know the formula for area, and area is the base times the height, or you might have heard it as length times width. Kind of the same thing, but it's these two multiplied together, and that's going to give an area of 81 centimeters squared. So that's going to be answer option D. Question 6. This is a regular pentagon. How many lines of symmetry it has? Well, you need to know about regular shapes. First and foremost means they're fully symmetrical. So a regular pentagon, regular hexagon, they're all symmetrical. And the nice thing about regular shapes is they have the same number of lines of symmetry as the number of sides. So the answer is going to be 5. And if I just try and draw in as to why, you could fold it along this axis here, this axis here, this axis here, this axis here, and this axis here. I'm pretty sure if we count that, that adds up to 5 lines of symmetry. So that's where the answer comes from for number 6. Number 7. I'm thinking of a number, I double it, and I add 14 to the result. So we have something, which I'm going to mark as x, we times it by 2, we add 14, and we get the result, and they're saying the result is 44. What were we thinking of originally? Well, if I think of this as sort of a journey, and I want to go in reverse, if I start with 44, I'm going to do the opposite, so I'm going to then minus 14 to get rid of the 14, then I'm going to divide by 2 to get rid of times by 2, and then whatever I'm left with should be my answer. So let's go through that. So 44 minus 14 leaves me with 30, 30 divided by 2 is 15, so I know that x is 15. And so therefore I think A must be my answer. Now what I can do with this, I could just quickly check. This is the kind of thing I would do if I had time at the end. Let's just say if we do 15 doubled, that gets us to 30. 30 plus 14 does equal 44. So actually I can check that that is the correct answer. And that would probably be the other way to do this. If you want to do like a trial and error approach, you could take the numbers they've given you in the multiple choice, double them and add 14 and see if you get to 44. So don't forget that because it is multiple choice, you can sort of use and abuse those a little bit to kind of give you some hints and things. That's one approach for these questions that absolutely can work. Number 8. How many degrees does the long hand on a clock face move when it goes from pointing at the number 1 to pointing at the number 7? Well, a really important fact is that 1 hour on a clock takes up exactly 30 degrees. Now, if you can just learn that, that's really useful. If you're not sure why that is, the reason is 360 degrees divided by the 12 hours that we have in a clock face gives us 30. But I would actually recommend, if you can, learning that little fact that 1 hour is worth 30 degrees, or one jump. And so between the 1 and the 7, if you draw it out on a clock, we're going to work out how many sort of hour chunk sections we're going through, and you could potentially sort of draw it out if you want to do between 1 and 7. That's totally acceptable. You're going to find, so there's 1, there's 7. You can sort of add the sketches in. You're going to end up having 2, 3, 4, 5, and 6. And if you then count how many little segments there are, there's going to be 1, 2, 3, 4, 5, 6 segments, 6 30 degrees is. And so that's the easiest way of doing it. Now I realise my sketch is a rubbish sketch, but because the 7 would be more sort of down here on an actual clock face, but it just conveys the point that that's how many segments we're going through. So 6 lots of 30 degrees is, and that's going to give us our answer of 180. which is the answer. So hopefully that makes sense. I know that, so you could also draw perfectly. You could draw yourself a normal clock and count that way. That would work too. Number 9. What weight is at A on the scale? Okay, well, we're going between 2.5 kilograms and 8 kilograms. So I know already the difference between those is 5.5. One way of doing this is to sort of try it. It looks like to me maybe it's going up in 0.5. So let's see what happens. So that would be 3, 3.5, 4, 4.5. So maybe that's my answer, but I want to really check to make sure it lines up. 4.55, 5.56, 6.57, 7.58. Yeah, that works. And so therefore my answer is going to be 4.5 kilos for this section here. And it's just about picking sort of a logical gap. And I could see roughly that if that was 5.5 and it looked like there was enough spaces, the actual maths behind it would be to divide 5.5, which is the gap, by the number of jumps. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And if you do 5.5 divided by 11, you get the answer, which is 0.5 kg. And that tells you how big the gap is. So if you can't spot it, that mathematically is how you'd work it out. You'd just do 5.5. You do the amount of value divided by the number of gaps, and that tells you how much each gap is worth. So that's a way of doing it. If it's a harder question, perhaps to spot than that one. Okay, so I left my house at 10:37 and returned 3 hours and 12 minutes later. Right, well first, so what time did I return? So for these, I always like to break up the steps. First thing, to get from 10 till 12 is 2 hours. After 12 comes 1 o'clock. So I think we're going to be in 1 something, so we can eliminate any of the 2's. And then I've got 37 plus 12. This is a nice one because it doesn't go into the next hour. So I think we can just add these up. So I think the answer is actually going to be 49 minutes, so I said it was 1:49, didn't I? So 1 hour 49, and of course just making sure to make the note that is 1:49 p.m. because it says a.m. but we've gone into the next hour, we've gone past the 12 o'clock, so we're now into p.m. I think is the answer. Calculate 8.5 times 5. A few ways to do this one. So one method would be to do 8 times 5 and 0.5 times 5. And this is probably what I'd recommend. 8.8 times 5 is 40. 0.5 times 5 means half of 5, and that's 2.5 as an answer. And now we can just add those together, and that's obviously 42.5. So that's a nice way of working it out. There are other methods which involve saying sort of 85 times 5. That would be 425, and then realizing that, of course, 85 is 10 times too big, so you divide your 425 back down by 10, getting you to the answer. There's a few different approaches, but I quite like just keeping it simple, splitting up into 2 easy bits I can do in my head. What is half of a tenth of 500? Well, a tenth of 500 is, sorry, a tenth of 5,000 is 500, because tenth means divided by 10. And what's half of that? Well, half of 500 is 250. So actually that was quite a nice one just to do in your heads. It's just about realising or doing it in order very carefully. 13. What are the coordinates of point A? Well, we always go along the corridor to -4, and then down the stairs, and I think that's between -3 and -2, so I think we've gone down to -4, so the first coordinate is -4, and then down the stairs, -3. So my answer is -4, -3, because that's the direct order, and yeah, definitely between 2 and 9. Yeah, I think that's my answer. So E, sorry, is my answer, I should say, for that one. Question 13, E. Oh no, sorry, that's -3, -4. -4, -3. I'm glad I wrote it here, and I'm glad I checked. -4, -3. I'm sure many of you are calling out at me at the screen. Number 14. What is the mean of this set of data? Well, it's a really important keyword, so if you don't know this, please add it to your Word and Mini book. The mean is a type of average, and it's worked out by adding all the numbers up and dividing by how many they are. So we often call it that we say it's worked out by doing the total divided by how many. So the total of these numbers is 20 plus 10, which is 30, plus 5 plus 5, which is 40. So we've got 40, and we're going to divide it by the number of numbers, which is 1, 2, 3, 4. So 40 divided by 4 is 10, and so the average is 10. And the average should always be not quite in the middle of the numbers, but it's meant to represent the numbers. It's meant to kind of sum up well, the average of what the numbers are. And so it's always a good idea to just do a quick logic check, and 10 to me does seem kind of in the middle of those numbers, whereas I'd been very surprised if 5 or 20 was the answer, because those don't really seem to be in the middle of these numbers, and so therefore it's probably not a very good average. And so that's the nice thing about averages, you can sort of logic check them to make sure, are they roughly in the middle? 15. What is the range of this set of data? Well, the range means the biggest value take away the smallest value, and I think here the largest value is 204. And the smallest value, just checking really carefully, I think it might be 12. Yeah, it's 12. And if I subtract those, I get 4 minus 2, which is 2. I want to do 0 minus 1, but I can't, so I have to borrow, making that a 10, making that a 9. So I think my answer is 192 is the difference between the biggest and smallest values. Again, if you didn't know that's what the range meant, that's fine, but please write it in your Word Mini book and learn it just like you would any other piece of vocabulary. Your maths vocabulary is just as important as any other bit of vocabulary. 16. The ratio of red to blue t-shirts in my wardrobe is 3 to 7. If I have 30 t-shirts in total, how many blue shirts do I own? Okay, so if we're splitting things into 3 and 7 parts, that means in total we have 10 parts. Sometimes you might also call this 10 shares, 10 bits, all the same thing. But the point is we're splitting it into 10 because 3 and 7 makes a total of 10. Therefore, I can now tell you that if I do 30 divided by 10, the answer is 3, and that is the value of 1 part or 1 share. So 1 part equals 3. So, in this case, the red, because it was red to blue, and this is more important to know as well, so red first, then blue, so it was red to blue. The red shirts had 3 parts, so the red had 3 times 3, which is 9, and the blue had 7 parts, so 7 times 3, which is 21. And the reason I've done both, even though I only wanted the blue, is I can now just check, does that add back up? And does this add back up to the number of shares? And yes, it does. So 9 plus 21 is 30, so I have successfully split my 30. If you ever share something and it doesn't add back up to where you started, you know something's gone a bit wrong. And so in this case, I want the blue ones. So that's going to be this one here. So 21 is my answer, because 7 times 3 is 21. Next question. 17. During the summer, I spent a total of 120 hours playing cricket and tennis. I split the proportion of my time spent and showed it on the pie chart. How many hours did I spend playing tennis? Well, I would say just looking at this, because that's a 90 degrees, I know that that is 1/4, which means this tennis must be 3/4. So I think the easiest way to do this is to realise he spent 3/4 of his time playing tennis. And in maths, the way we work out 3/4 of or 3/4 times, by the way, this is really useful to know, of in maths and times are the same thing. So 3/4 of 120 is the same as 3/4 times 120, and luckily the method for these is exactly the same. We're going to multiply by the top number and divide by the bottom. It's always a good idea, if you can, to divide first, because it's going to give you the same answer, but dividing first is easier. So 120 divided by 4 is going to be 30, and then 30 times by 3 is going to be 90. And so I think they spent 90 of those hours playing tennis, which seems like an excellent use of a summer holiday. Really good fun. 18. What is the next number in this sequence? Well, that looks to me as it going down by 6. 6 again, so at this point I'm pretty confident I spotted what's going on. So 0 minus 6 is going to be minus 6. So that's a descending sequence that ends up in the negatives, but that's allowed. That can absolutely happen with sequences. There's no reason to distrust that one. Number 19. What will be the 12th term in this sequence? Okay, so the first things first, you've got 1, 2, 3, 4, 5. So you could work out the 6th term, 7th term, 8th term, and just keep going. That's going to be one method. But there is a better way for these questions. I'm going to try and show you the better way, just because everyone, if they need to, could just sort of count it out and work out the answers. And obviously it looks to me as it's going up by 5 each time, plus 5, plus 5, plus 5. So it's quite a simple sequence. But it's to use what's called the nth term. If you can work out what the nth term is, you can work out any number in a sequence. So even if this was 121, you'd be able to work it out just as easily. The way to work out the nth term is to spot the times table it's based on. So in this case, I already said it's going up in 5s each time. So this is based on the 5 times table. And what I mean by that is, what times table goes up in 5s? Well, it's the 5 times table. So it's going to be based on 5n. However, the 5 times table normally starts at 5. This times table starts at 1. So our times table, instead of being the 5 times table, which is what this one is, the 5n, we want it to be the 5 times table that starts 4 less. So this is your nth term, and the reason this is really useful is you can now use this to work out any sequence by just substituting in the term you want to know. And so since we want to know the 12th term, we're going to just substitute in 12 instead of n, so 5 times 12 minus 4 is going to give us our answer. And 5 times 12 is nice, easy maths. You need to know it's obviously 60, and then 60 minus 4 is going to give us the answer of 56. So I'm pretty sure that's my answer. And I just think the nth term is so useful, especially if they were a bit meaner, and if they asked you to work out, for example, the 100th term. This is obviously going a bit off pace there, which is an example. What would the 100th term be? Well, to count out to 100 would take a really long time. But if you have the nth term, you just know that, the answer is going to be 5 times 100 minus 4. And that's so much quicker that obviously it's 500 take away 4, which is 496. That I think it's a method worth learning. So, basic nth term, quite a good skill, and you may even see questions that ask you for the nth term, so it is something that I think you would definitely want to know about and be able to do comfortably. But I'll rub that out now because that was just a theoretical example for this one. That's all we needed to do, and so then C is my answer for this last question here. So hopefully that's useful and hopefully that makes good sense. 20. What number replaces the question mark? Well, I know that triangle is 24, so they're all the same, so I think that's going to be, it's not 6 plus 6 plus 6, because that would add up to 18, so maybe 8 plus 8 plus 8, that adds up to 24. They have to be the same value, which means I now know that this is an 8. I also know down here that star times star is 25, or the only thing can do that is 5 times 5, so star must be 5. So now I've got something, take away 5, add 8 equals 9. So if I sort of do the reverse, 8 minus 9 would be 1, plus the 5 would be 6. So does that mean that 6 minus 5 plus 8 is 9? I think it does. Let's just check it out. So 6 minus 5 is 1, 1 plus 8 is 9. So yeah, I'm pretty sure that the square must be equal to 6. So that's my answer of A. So you can see I filled in the things I know, and then knew, and then used that to work out what I didn't know. 21. This tally chart shows the number of medals each team won at the sports day. Remember, tallies, each set is a group of 5, so that's 5, 5 and 5, so that's going to be 15. That's going to be 5 and 4, which is 9. 5 and 1, which is 6. 5, 5 and 2, which is 12. How many more medals did teams A and B win collectively than teams C and D? Okay, well, collectively means all together. So I think teams A and B won a total of 24. I think teams C and D won a total of 18, and the difference between those two is a subtraction, so 24 minus 18 is 6. So I think the difference between the two groups is 6, which means my answer is D. Hopefully that's nice and clear. 22. Oh, I like this one. Calculate 0.042, so 0.042 divided by 1,000. Now, with timesing dividing by tens, hundreds and thousands, it's really, really important that you know that basically for every 0 is how the decimal moves, and then plan a little bit. Do you want it to be moving bigger or smaller? So for these ones, it's really important no one falls for the mistakes of C and D, because obviously these numbers are getting bigger, they're getting larger, so that can't be the correct answer. So probably actually the first thing I would be doing is crossing out C and D before I've even done any maths at all, because they're obviously wrong, because those numbers actually got bigger, and hopefully we'll know that if we divide, a number should get smaller. The next thing is we've got to think about what direction. What if I move the decimal this way? That's making the number bigger, so obviously that can't be the direction we're doing today, so instead I've got to be obviously moving the decimal to the left. And then the number of jumps is equal to the number of spaces, so I'm going to move it 1 jump, 2 jumps, 3 jumps. Notice I don't have any zeros here, but I can sort of add them in, just so I can sort of see what the number would look like. So if this decimal has gone from here to here, it's no longer there, my new answer is going to be 0.000042, which I'm pretty sure is answer option A. And the nice thing about these again is once you've looked at your answer, you can just check. And so if this is where it was, I could just pop this in the same place. So 0.0 here. And let me just check, does that look like it's moved 1, 2, 3 spaces? 1, 2, 3 spaces? Yes, it does. So I'm very confident now that A is my answer. And actually probably that's what I would have been doing, is I've been looking at A and B and E and sort of seeing which ones match up and which ones have moved the right number of spaces. And I definitely think it's better to think about moving decimals than it is to think about, so for these questions, it's better to think about moving decimals and adding zeros, because moving decimals works whether it's timesing by hundreds, big numbers, small numbers, whereas adding zeros doesn't really work with these in the same way, because you're not really adding zeros to the back of it and in quite the same manner. So 23. Let's just move that to the side slightly so we can all see all the options. I got an online voucher for £50. I buy 2 games at an average price of £9.50 each, and 3 games at a price of £4.20. How much of my money is left now? Well, 9.5 or £9.50 at £9.50 is going to be 9 plus 9 is 18, plus 2 halves is 1, so that's going to be £19 we've spent so far. And then £4.20 times by 3 is going to be £12.60, and the way I do that in my head is I do 4 times 3, which is 12, and then 20p times 3, which is 60, so that's where the £12.60 comes from. So in total, we spent the £12 plus the £19, so that's going to be £31.60 spent. And so if we've got £50, we need to do the difference between those. So for that, I'm going to just do a nice subtraction. So you've got £50, and you have added in the zeros to make it easy. Take away the £31.60, and then whatever's left is my change. So I'm going to start borrowing, so that becomes a 4, that becomes a 10. I've got to borrow again to get down to here, so that's going to become a 9, and that becomes a 10. Obviously 0 take away 0 is just 0. But now we can do the 10 take away the 6, which is 4, so 40p. Make sure we keep the dot nicely lined up. Remember, when you're doing subtractions, all the units should be lined up beautifully. 9 take away 1 is 8. 4 take away 3 is 1. So I think my final answer is £18.40, or answer option D. On then to 24. What is the perimeter of this shape? Perimeter means the outside, so first things, please don't just add them all up, because look, we do not yet know what this side is, and we do not yet know what this side is. We have to add up all the sides, and this question involves working out some sides. So I'm just going to do a bit of colour coding so you can see. Hopefully you can agree that these two red lines are actually going to be the same length as this red line on the left. So if I know this whole thing is 17, and this is 7, this bit here is going to be 6. And if I then do the same logic along the bottom, this whole purple length is 18. I know this little bit here is 7, so the remaining amount must be 11. And using that logic, I've now labelled all the sides. I can now add everything up. And actually a really nice trick as well is I know that 7 plus 11 is going to be 18, so actually I can ultimately just do 18 plus 18, which is the sum of those two purple sides, plus this 13 here, plus the sum of these two sides, which is 6 plus 11, which is going to be 13. And if I add all these together, I'm going to get my answer. So 18 plus 18 is going to give me 36. And then 13 plus 13 is going to be 26. And so 36 plus 26 is going to be 62. And obviously make sure, because it's perimeter, the units are centimetres. So 62 centimetres is my answer. 25. What is the area of the shape in question 24? Brilliant question. For working out area, you want to split the shape into 2 small, easy rectangles. And so I'm going to divide the line along this one, just because I can spot that this one is then going to be 7 and 6. So if I was to draw it out over here separately, you've got a little square of 7 times 6. As we said earlier, area is the base times the height, so 7 times 6 is going to be 42. And you've also then got this larger rectangle on the bottom. Just make sure you label it carefully. The side along the bottom is going to be 18. It's that long side along the bottom, and that tall end along the side there. So 18 times 7 is obviously a little bit more challenging, but you can use any method that you need to work it out. 18 times 7 ends up being 126. And then once you have those two values, you need to add them together, which gives you 168. Now, because it's area, the answers do need to be centimetres squared. Now, luckily, all of these are centimetres squared, but that is my answer. And again, for multiplication, any method that suits is absolutely fine, absolutely usable, and therefore totally okay. Right, on to the last couple. So we've got 3 more on this page. So, 26. I have 3 items of luggage, which weigh, 1,032 grams, then 13.9 kilograms, and then 21,415 grams. What is their total weight in kilograms? Now, since it wants me to work out the weight in kilograms, I might be tempted to convert everything to kilograms first. You could also convert everything to grams, but before we add them, they do all have to be the same units. Now, if you're comfortable with decimals, I think the thing that's going to save you the most time is to put everything into grams. But if you'd rather avoid decimals, maybe putting things into grams, into grams first, which means it has the decimals, and then putting it into kilograms at the end is the best way. But for now, I think I'm going to just do it using everything in grams, because it also means I have to change one thing. I'll just everything to kilograms, and then I have to change one thing at the end, which we might just doing the answer. So 13.9 grams is already done in kilograms. To convert this into kilograms, I'm dividing by 1,000, so the decimal's here, so it's going to move 1, 2, 3 spaces, and the decimal will end up here, so that's going to be 1.032 in kilograms. And for this one here, same thing, the decimal's got to move 1, 2, 3 spaces, so it's going to be 21. So actually I'll write this up here at the top. So you've got 21.415. Now, something I teach all my kids to do, especially when we're doing an addition or multiplication or anything involving decimals. I just realised it's off the top there, so let me move that down slightly so we can see nicely, is to please make sure that you add in these placeholder zeros. You can actually even add one in here, just so you don't make any mistakes about where the numbers go and what numbers you're adding, because everything has its place. So here we've got the tenths, then the hundredths, then the thousandth, all nicely lined up. The unit's the same and the tens the same, and that's really important. So let's get to adding. 5 plus 2 is 7. 1 plus 3 is 4. 9 plus 4 is 13, so we're going to carry the 1 and write the 3. 1 plus 3 is 4, 5, 6, and then 3. So I think in total my answer is 36.347 kilograms, and because it was in kilograms, the answer is going to stay in kilograms. I don't have to do any changes, or there's nothing else going on with this one, which is perfect. So my answer is going to be this. Where is it? Is that 36.347? Yeah, so answer option D, which is perfect on the side there. So hopefully that makes sense, and it's just really important with these, I do think, to make sure you're labelling all nicely and all clearly. Hopefully it's all good. So let's just shrink that off to the side so it sits there beautifully. And adding those place values in, really useful. Also a good trick actually when you're comparing decimals, to add in those placeholding zeros so you can more clearly see how big the numbers are. What is the smallest angle between 2 clock hands at 3:30? Well, this one definitely requires us to have a nice accurate picture. So obviously it starts at 12, and we have 1, 2, 3. So the first hand is going to be at 3. This is the hour hand pointing at 3 o'clock. But at 3:30, of course, it's going to be slightly further down. So currently that's pointing at 3. The minute hand's slightly easier. It's going to be pointing straight downwards to the 6 at 3:30, because that's obviously half an hour. But I think this is a mistake that a lot of people make. You've got to take that hand. So actually, let's put some labels in. So here you've got 1, 2, 3. Here's down at 6. This hour hand would actually be halfway between 3 and 4. So it's going to be kind of like that. And what that means, if I go 3, 4, 5, and 6, and we work out how many sort of splits there are, how many. So we've got 1:30. 2 30s, and a half of 30, which is 15. So I think we need to do 30 plus 30 plus 15 to get our answer. So you can see that clearly. So you've got between the 3 and the 6, but it's halfway between the 3. It's not actually pointing directly at the 3, because in half an hour the hour hand would be between the 3 and the 4, and therefore one full hour, 2 full hours, and a half an hour adds up to this. And sorry, I should finish it off. So 60 plus 15 is 75 as my final answer. Okie dokie. How many factors of 12 are there? Well, if we do ourselves a little factor bug, I like the factor bug. So 1 times 12, we've got 2 times 6, we've got 3 times 4, and because the next number I would check, so the nice thing about factor bugs, you do them in order, so you check 1, check 2, check 3. Now it's our turn to check 4. Since we've already done it, we now know we can stop checking We don't have to check the rest, and that's the advantage of doing factors in order. Once you then come to one you've already done, you know to stop. Whereas if you just randomly write down factor pairs, you may not know when to finish. So I think that means there are 6 factors in total. So there's my answer C, 6 factors. On then to 29, just move these over again. Reflect triangle ABC in the x-axis. Well, very kindly they've labelled the x-axis. So this one here, so we're going to be reflecting in this direction. And so if this was going to be a 4 and a -5, it's going to still be -5, but now it'll be -4. And if this one here was A, was also at 4, but -7, it's going to stay at -7, but it's going to still be down to -4. And if this corner up here is still -7, but that looks to me as though it's a 7, it's going to go all the way down to -7, which is perfect. So there's my shape. I might even just fill it in just so I can see if it looks nicely reflected. And it should be pointing in a different direction. That gap should be about the same. So yeah, I think that's a pretty good drawing so far. And then reflect this new triangle in the y-axis. Okay, well, this is the y-axis here. So we're going to reflect it the same way. So now this 4 will stay the same. But if that's going to be -5, it's going to be reflected to +5. And if that's going to be -7, this one's going to be reflected to +7. And if this one is going to be going all the way down here to -7, but it's -7 on this side, so it should still be the same thing here, but it needs to be at 7. So I think that corner there. Okie dokie, there's my sketch. And again, yep, that looks like it's roughly the same height on the opposite side. What are the coordinates of point C? All right, let's follow exactly what happens here. So there's C, and that's going to get copied to this corner here. And it's the one closest to the inside, so that's going to get copied to this corner here. And I'm pretty sure that is 5, and then that should be on the line 4. So along the corridor 5, down -4. So my answer is 5 - 4, which is number E, 5 - 4. That one there, off on the side. So hopefully that makes sense. A few steps to follow there. That's a fairly good problem question with quite a few steps, but hopefully not too challenging once you've seen it written out. Question 30. This is an equilateral triangle sitting inside a quadrilateral. How many degrees are there in angle X? Oh, this is a cool question. Well, the first thing I think we need to do is to work out, well, in every equilateral triangle, and this is just a fact, so it's not so much working out, but what these angles are. And you can, I suppose, work it out is if you know that a triangle adds up to 180 degrees, and an equilateral triangle, all the angles are the same, we've just got to do 180 divided by 3 to work out what all of these angles are, and they're each going to be 60. So I know this little one here in the corner, which is the important one for us right now, is 60 degrees. So if I can work out what the whole angle in the corner is, if I take away the 60, I will be left with just this little bit in the corner here, this green bit. So our plan is to work out the red angle, which is the whole corner of that quadrilateral, take away the equilateral that we know, which is 60, and it should leave us with the green angle, which is the angle X. So how am I going to work out the angles in the quadrilateral? Well, I do need to know that, by the way, it says not drawn to scale, so the fact that this might look like a right angle, I'm not allowed to just assume it is a right angle and put 30. I actually have to work out what it is. There's no assumptions allowed. Well, luckily I know that all quadrilaterals angles add up to 360. So if I take away the 3 angles that I do know, so this angle in the top right hand corner here is a 90 degrees, that's what that symbol means, it's a right angle. And I take away 58, and I take away 111, whatever I'm left with will be this red angle here. And so 360 take away 111, which is going to be 249. 249 take away 90 is going to be 159. And 159 take away 58 is going to be 101. So this whole angle, this whole red angle, is 101. So if the red angle is 101, and I just want to take away the blue angle, I've got to do 101, subtract 60, and that will give me my answer of the green one. I'm pretty sure 101 take away 60 is 41 degrees, so that's going to be my answer for this question, 41 degrees. Okay, I'll hide Billy out of the way so we can see all the answers for this one. 31. 31. Today is a Thursday. What will the day be in 38 days' time? Right, the trick for this is not to count out all 30 days, but it's to realise a cool little trick. If today is Thursday, what day will it be in 7 days' time? Well, in 7 days' time, it'll be Thursday again. So if I count up in sevens, the day's not going to change. So the first 7, it's a Thursday. Then after 14 days, it's a Thursday still. And after 21 days, still a Thursday again. 28 days, still a Thursday. 35 days, it's a Thursday. And so now if I know that on the 35th day is a Thursday, I've only got to count up in days from 35 to 38. So if 35 is a Thursday, 36 is going to be Friday. Let's write it out. 36 is going to be a Friday. 37 is going to be a Saturday. And 38 is going to be a Sunday. And that's my answer. And you see it's much easier because we're only doing it for a couple of days. You can be really methodical for the last 4 days, whereas you would not want to have to write out 38 days or like a whole calendar almost. It would just take far, far too long. So that trick of going up in sevens I think is really important because it makes it far, far more manageable. So I think my answer is C, Sunday, question 31, because of that reason. And you could even then write it out. And the cool thing about this method is, because you're counting up in sevens, you'll never have to do more than 6 of these, because otherwise you'd be just going up in the next 7. So, 32. I am looking east. Due east just means looking east. So we might need to draw ourselves a little picture for this one. So there's my never eat shredded wheat. I've also heard naughty elephants squirt water, or never eat soggy waffles. They're all good, whichever method you have for remembering. Sounds perfect to me. Just go with the one that works for you. So if I rotate 235 degrees anti-clockwise, where will I be facing? Okay, well I'm facing this way. Let's split that up. So 235 is the same as doing a 180 degree turn, and then with a bit more left over. So the difference between 180 and 35 is going to be 55 degrees or so. 33. This is just a good BidMaths question. So for these, I recommend doing it in stages. I'm just start writing things out above. So first of all, always get your brackets out of the way. So there's my 30. And now I've got a series of additions and subtractions. And the nice thing about additions and subtractions is you just do them from left to right. So we need to do 19 plus 24 for starters, and then 19 plus 24, whatever the answer that is, we'll minus 12, and whatever the answer that is, we'll add 30, whatever the answer is, we'll add 4. So 19 plus 24 is going to be 43. 43 minus 12 is going to be 31. 31 plus 30 is going to be 61. And then 61 minus 4 is going to be 57. So I'm pretty sure my answer is just 57 for this last one. 34. On Friday, I did 3/4 of my homework. On Saturday, I completed half of what remained. How much was left to do on the Sunday? Okay, well, if I've done 3/4, that should mean it's logical that 1/4 is left. If I then did half of a quarter, remember earlier I said that our of means time, so half of a quarter, that means 1 times 1 is 1, 2 times 4 is 8, it means I've done 1/8 of it. But the nice thing about that is actually I've done 1/8 and there's 1/8 left because I've done half and there's half left, so my answer was 1/8. That one's a difficult one. That requires a bit of understanding of fractions, the fact that we know that they add up, but also you can use the fraction to describe different parts. So at the point where we were just going into a Saturday, there was a quarter left over, and of the quarter we did half of the quarter, which means half of the quarter was left. So that's where the 1/8 came from. So hopefully that makes sense. Bit of a tricky one, but really not based on the math so much as just the wording. I think that's what made that one a bit mean. 35. Last question, guys. You've done really well. I went to the shop and bought 3 rubbers and 5 pencils at a total cost of £3.70. So 3 rubbers plus 5 pencils equals £3.70. My friend went to the same shop, that means they're the same price, and got 6 rubbers and 2 pencils. And that cost them a total of £3.40. Okay. Move these off to the side so I can just write underneath them. What is the cost of 1 rubber? Well, this is a bit tricky. So this is obviously the last question, so they've also made it a bit of a hard one. What we could work out, I suppose, is that we can't just take them away, sadly, because the difference is 3 rubbers and the difference is 3 pencils. So we could work out that the difference between 3 rubbers and pencils, but I don't think that's going to work very easily. I think the best way to do this is actually to change these so they line up. So I'm going to modify this top one, that if 3 rubbers and 5 pencils cost £3.70, 6 rubbers and 10 pencils, i.e. twice as much, is going to add up to double £3.70. And double £3.70 is going to be double 3 is 6, double 70 is £1.40, so I think that's going to be £7.40 it would cost. And the reason I've done this is now the amount of rubbers is the same. So if I know that 6 rubbers and 2 pens is £3.40, and 6 rubbers and 10 pencils is £7.40, I know that the difference between these guys' prices is going to be due to the difference in the number of pens, or pencils it was. So that means I know that 8 pencils is going to cost the difference between £3.40 and £7.40. And that is, of course, £4. And now that I know 8 pencils costs £4, I can work out that 1 pencil is going to cost 50p. And if I know that 1 pencil costs 50p, I can use that here to help work out. So it doesn't really matter which one we do. Maybe I'll use the top one just because it's at the top. You could use this for either one. So if I know then that he bought 5 pens and it was 50p, that means I can rewrite this to say that he spent 3 rubbers plus £2.50, which is what equaled the £3.70. Which means I then know that the 3 numbers are going to be just the total money, take away what he spent on the pencils. So that's going to be equal to £1.20. And if 3 rubbers cost £1.20, 1 rubber is going to cost a third as much. So that's going to cost 40p. Or 40p, which they've written like this. So that was a tough question to finish on, and it required quite a bit of logic there to sort of work out, but it's all about spotting the difference. And really the trick to this question is what makes it really hard, was the easiest way to do it was to get 2 different facts, 2 different statements where something, in this case the rubbers were equal, but the pens were different, or the pencils were different, and that means you knew that the cost was all down to the difference in the cost of the pencils, so you could work out the cost of 1 pencil, and then you could start working out the cost of the individual pieces. But I think that was a tough question, so a really big thumbs up if you managed to get question 35 correct, especially within the time limit. Very well done. We're now going to move on to the non-verbal reasoning section. So for each of these, you'll see at the top they do lots of examples where you have the answers at the top of each example page, and the practice questions, I'll go through the answers to practice questions at the start of each of the actual individual topics. So you can see here all the practice questions in one go, all the examples in one go, but we'll start going through. And actually the first thing for us to go through together are the series questions. And so looking at this first one, here was our example. Oh, sorry, no, not series, because that was one more example. One more try. Here it is. Sorry, take that back. The first section is going to be find the figure like the first 2, and here's the answer to the practice question where we had 1, 2, 3, 4, 5, and 1, 2, 3. So I think these were all odd. So we want something that joins in with these. So it's not that one, not that one, not that one, not that one. So B is the only one that joins in because it's the only one that's also odd. And that's the pattern. So we're analysing quite what do these guys have in common. And then once we know what they've got in common, we're working out which one sort of joins in with the group. Looking at 36, I can actually see these are both rotations of each other. If I flip this one around, it would be an identical shape. So we want something that's also identical, and actually I can show you exactly what I mean. I might as well with my little snipping tool. So if I take this one on the left and just cut and paste it for you and rotate it around, hopefully you can see it's an exact copy of this one on the right. So I've rotated that left one. Look, that's what it looked like, and that's what it is now. So we need a shape that matches. And if you look, A does not match. It's the wrong way round. B does not match. but C is a pretty good match. So I think C is my answer because it is the only other rotation of those two shapes, whereas all the others are in fact their mirror images. That's why that is the answer. That's why the other ones aren't. So for 37, right, we've got a 4-sided shape with 1, 2, 3, 4 things inside, and a 5-sided shape with 1, 2, 3, 4, 5. So I think the number of sides needs to match the number of pieces the shape's made from. So definitely not A, definitely not C. That's got 1, 2, 3, 4, 5, 6, and 6 sides. So I think B is going to be my answer for this one probably, because all those others look like they've got too many or too few. 38. Okay, well, we've got shapes inside. Is it the number? So I can see here I've got a 6-sided shape and a 6-sided shape. That adds up to 12 sides inside. And here, look, we've got 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so I think the number of sides inside the shape needs to add up to 12 sides in total. So A, that adds up to 9. B, that adds up to 9, so it's not that one. That's closer, but not quite right. E has jumped out at me. 4 plus 4 plus 4 adds up to 12 sides inside, and so I think E is my answer, and that would be my reason why. For 39, okay, well, we've got black, grey, white, grey, white, white. So it looks to me as though there's some pattern. So is it the top point? The colour of the top point is the colour of the top circle. The colour of the top point is the colour of the top circle. The left colour is the middle circle, and then the right colour is the bottom circle. I think that must be it, because yeah, look, top, left. Yeah, I think we've got it. So let's see which one's made the rule. So A doesn't match the top. B, the tops don't match. C, the tops do match. And actually, I think C is looking pretty good right now. Let's just see, well, not D and not E. Yep, so C is the one. And again, just to follow, the top one was white, so the top one was white. The left one was white, so the middle one was white. The right one was grey, so the bottom circle was grey. I think that's going to be my answer. On then to number 40. So for this one, we've got a 1, 2, 3, 4, 5-sided shape. 1, 2, 3, 4, 5, 6, or 7-sided shape. So it's probably not the number of sides, but it does look symmetrical. So is it just simply that we've got a symmetrical, horizontal line of symmetry, we'd call it a symmetrical shape here and here? Well, A looks pretty symmetrical to me, but B doesn't. C doesn't. No, so I think that might be it. I think it just might literally be A, because it needs to have a line of symmetry, specifically a horizontal line of symmetry for that one. Gosh, and actually looking at 41, it looks like it might be a similar thing going on. We've got a horizontal line of symmetry within the pattern for both of these. Not A doesn't, B doesn't, C doesn't, but D does. I think it might be that simple, you know. I think it might be we've got 2 lines of symmetry. Questions back to back. That's quite nice of them. Right, 42 then. Well, we can eliminate definitely B and E because it needs to have this oval shape on top. So the overlap requires that to be on top. And then is it just that it's always on top of the littlest side? That's the littlest side. That's the littlest side. Whereas those are 2 look like similar sides. C, though, has got it on the smallest side. D doesn't. So is the answer C? I think it might be, you know, because there's not a lot else going on with these. So if there's not that many different moving parts, it kind of only leaves you really with one choice for what the answer can be. Yeah, gosh, I think that's it. I think it needs to be overlapping on top, and on the oval needs to be on the smallest side of the shape. On now to analogies. So for these, we need to make sure we're applying the same change we've seen already. So we've got, I think here we've got 1, 2, 3 black dots and 3 white dots, and it looks to me as though simply the white and black are swapping. So the ones that were black become white, the ones that were white are black. So if we apply that same change, we can see it's only this one here that should end up going to be black, which I think eliminates all of these. C is looking pretty good right now, and yeah, I think that's going to be my answer, C, based on that same change. So for 44, okay, so the grey one has moved up 1 place to here, and the black one has moved 1, 2, 3 spaces. And if we were to be more precise, I'd say the grey one has moved anti-clockwise 1, and the black one has moved clockwise 1. So if we try that same thing clockwise 1, 2, 3, and then if the grey one anti-clockwise, sort of back 1, would be something like that. So I want the black one down here and the grey one here. Well, that's got the black one in the right place, and that one seems to have got the grey one in the right place. So A is looking pretty good. That's, what's the difference between these two? It's where the black one is, so the black one's on B is whatever, so no, not that one. Grey's in the wrong place there. They're both in the wrong place there. Yep, so I think I'm pretty happy with answer option A being the right answer for that. And so hopefully you can see from those two examples it makes good sense. We've gone through and we've moved the shapes twice. For this one, and we're just sort of applying the same changes. In fact, sometimes these analogies are called applying changes questions, because just applying the same change. Right, on then to 46. So I noticed that the outside colour has become the inside, and the inside is on the outside. So I guess we're going to need to have a white inside and grey outside. So that eliminates these two. And then in terms of the sides, it goes from 3 sides to 4 sides. Seems to become 5 and 6. So I wonder, is the middle shape doubling in sides and the outside gaining a side? Well, if that was the case, the triangle would gain a side and become a square, and then we'd have, oh gosh, a 10-sided shape inside. So I think that needs to then be not A, not B. Let's just check. Does that have 1, 2, 3, 4, 5, 6, 7? Oh, it's only gone up 8. So maybe it's not doubling. Maybe it's just plus 3, because we've gone from 3 sides to 6 sides. So that's plus 3. We've gone from 5 sides to 8 sides plus 3. So I still think that's we got the gist right. I think D is the right answer. So the colours swap. The outside shape gains 1 side, and the inside shape gains 3 sides. I think that's pretty much spot on. And yeah, that explains D quite nicely. Okay, 47. Well, the white ones have become black. The grey one has become white, and the black one has become grey. We maybe apply that same rule. So the grey became white, so these two grey ones would become white, which means only really E is the viable option for that one. And then let's just check to make sure. I guess have the black ones become grey. No, sorry, the white ones have become black. So here have the white ones become, and yes it is. So I think E is definitely the answer there. We've got those rules down to a T. Very good. Okay, so it looks to me as though the bottom shape has rotated to point upwards, and the right shape is, well, not rotated, you could say it's a 180 rotation, or it's a reflection, so that's been reflected up, and this one's been reflected left. The top one's, so if you kind of consider that corner as pointing this way, it's now pointing this way, and if that bottom one was pointing down, it's now pointing up. So if we apply the same change, we're going to have the sort of tall side on the left, so that's swapping that, and then you're going to have the pointy side here, sort of pointing down more, and this side pointing up more, something like that. Way again, it was pointing up and down, so it's now swapped, and this was pointing, the big one was on the right, and now the big one on the left. So I think that's a fairly good drawing. Let's see if that lets us eliminate anything. Well, actually D kind of matches what I was going for, where this peak, if you look, is the highest peak, when this one was the highest, and then this was the bottom, now it's the top, bottom has become the top, top's become the bottom. So I think for 48, the answer is D. 49. Well, all that's really changed, I think, is another rotation. So let me just have a look and see. Get my trusty snippet tool. Again, I know you can't do this in the real exam, but don't forget, of course, you can always rotate the paper. So you can physically pick up and rotate things and see. So it looks to me as though that shape has become this. I would say that's almost an exact copy. So if we do the same thing, and in terms of being precise, I would describe it as a rotation. What direction? Clockwise by, well, let's work it out. So it was here. Oh, it was here. So that's 90 degrees. That's 180 degrees. So I think we need to have a 180 degree rotation. So let's do the same thing. So there's your 90. There's your 180. And I think that pretty much spot on maps up with A, actually. So that's quite nice. It's the first one for us to look at. So I think A is my answer for that one. Hopefully that's clear, and hopefully you can see how those rotations help you to sort of spot the answer. And again, I know you can't obviously snip it out and start cutting and pasting the paper, but you can physically pick up and rotate your paper, and that obviously helps quite a lot. On then to the matrices. With these matrices, you just need to make sure that, of course, you're completing the patterns in a row. So all black, all white. So these are all going to be grey, so you eliminate all the ones that aren't grey. And it seems to be every row needs to have circle, square, triangle, but also if you look, every column needs to have circle, square, triangle. So there are things to spot both but in fact diagonally as well, circle, triangle, square. So the pattern needs to be able to work horizontally, vertically, and also diagonally. And the reason I mention that is often diagonally is overlooked, but that can be really useful. And so the example I'll give for that is if you look in the diagonals here, these will all be the same shape, these are all the same shape, these are all the same shape. So it's really easy to spot that this one here needed to be a circle. And so sometimes the diagonals are actually even faster to spot than the rows. So just something to be aware of. Okay, so that grey one, it just seems to be moving one space up each time. So it's going from here to there to there. So yeah, we're walking up. This one seems to be still walking around. Now obviously I can't see it here, so I'm going to have to assume, I suppose, that they're on the same position. So there's the grey one walking around, then it's going to be here. So I think we need to have the grey one here. If you look, so it's a 1. If I draw on the same shape with its journey, so it goes here, 2, 3, 4, yeah, and then we can see that that's that one. So this is the one where we don't know, and if that's correct, the next one should be here, and look, there it is. So I think that's our grey shape in the top corner, so let's actually just eliminate any that don't have that correctly. So that's not got the grey shape, that's not got the grey shape, but the remaining ones do, so we got rid of some of the options. And the black one seems to be moving 1, 2 spaces, then 1, 2 spaces, then 1, 2 spaces. So it's moving 2 spaces around. So from here, it's going to be sort of down there, 2 spaces further on. I think of the two, that's not E, that's not D. It is, however, A. So my answer for 50 is A. Looking at these ones, okay. Well, they all seem to have so 3 lines always. So none of the 4 lines we can eliminate. Oh, in fact, just looking at it, are these all the same? Yeah, look, so looking at the columns, those are all the same shape. Those are all the same shape. So these will need to be the same shape. And then it seems to be another rotation. So again, I'm going to get my trusty snipping tooling out, and you guys need to start actually physically rotating the books so you can work out what rotation's going on. So we go from this shape here to this shape here, so that's a 90-degree rotation, to this shape here. So I think every time you go down a level, you're rotating by 90 degrees. So let's do the same thing to our rightmost row. Let's paste that. So one 90-degree rotation looks like this, which does match. Another 90-degree rotation is going to look like this. So this is going to be my answer. And that one matches. That's a pretty good match for A. C looks close, but no, I think A is better. So 51. My answer is A as well, because it's a rotation. Okay, 52. Well, they've all got 3 triangles, so you've got nothing to eliminate there. Are these all similar shapes? Not quite. So you've got that and that. Well, kind of interesting. So these are reflections, if you look. That's the same, that's the same. So I wonder if these are going to be reflections of each other as well. I can actually cheat and do that sort of in here. So if I take a snip, I wonder if I can flip it and see. So that's what it currently looks like. If I was then to flip it from left to right, it looks a bit like this. Tough to sort of spot, but that does look like a reflection to me, which means then the answer is going to be, is it B? Yeah, I think B looks pretty close to that one. I think so. So I think that's my answer for 52. It's a reflection. 53. Okay. Well, it's definitely going to be grey, because look, all black, all white, all grey, so let's get rid of the white ones. And then in terms of where we're going, that's top, left, right, right, top, left. I noticed, I was about to say we never have one at the bottom, but no, there's one at the bottom there. I was wondering if it was going to be a set of the 3. Maybe as we go down, so top, right, bottom, so that's rotating. Left, top, right. Yeah, so I think I've got it. So I think as we go down the columns, it's rotating 90 degrees each time as we descend. So that means it's going to be right, bottom, left. I think we're expecting a grey shape along this left wall here, which is E. So I think 53, my answer is E. 54. Well, it looks like really there's a combination thing going on here where this shape and this shape show up in that first one. So these should be showing up in this, yeah, and I can see it behind. And is it the case that the the top one. So it's no, look, so if you look at the top one here, or the right one, not the top, but the right one goes behind, the middle column goes in front. So we're expecting to have this in front and all of these behind. And what kind of shape? I'm not quite sure. Well, I guess it's probably, looking at the options, it's probably going to be some sort of arrow. So first off, first rule, we need this one to be in front, so only this little thin oval. So B doesn't have a thin oval in front, C doesn't have a thin oval in front, but the remaining ones do. Then I think all of these right-hand ones were behind the shape, so I think all of these larger ovals need to be at the back. And that right one there is not at the back, so it can't be A. That one there is not at the back, so it can't be D. Whereas all of these are at the back, so I think E must be the answer for 54. Alright guys, doing really well, last two of this section. So we've got 2 grey, 2 white, and 2 black, and 2 white. Okay, not sure about that one. What about this? Well, the fact that they're the same pattern in the column means maybe I should be looking at the columns. So the black ones become grey ones. The black ones have become grey ones. Okay, that looks like a rule. So then did the white ones become black ones? Yeah, and the white ones here became black ones. Right, so I think it's definitely some sort of column rule. And as we go down, I think black becomes grey. I think white becomes black. Look, there's white becoming black, and there's white becoming black. Yeah, so white becomes black. Which probably must mean then black. So white becomes... which one becomes white? Grey becomes white. So yeah, so there's that one grey. Yeah, so then grey becomes white. That's obviously the last combination, so that does make sense. Okay, so applying those rules, this white one is going to become black, so we should have a black one in the top corner. Then the grey ones are going to become white, so we should have 2 white ones here and here. And the last one, I don't know if I've actually got a grey colour. Oh, I sort of do. This one here should end up being grey. And so if we try and match that up, which one matches with that, it's probably going to be D, based on my imperfect, but close enough picture. D. And guys, don't forget the power of sort of making notes and the power of sketching things out. It's really a good idea for all non-verbal questions, but especially these where there's lots of changes going on at once. Right, last question, 56. Well, we've got, looking horizontally again, or diagonally again, look, these are all the same shape. These are all the same base, they're all the same big shape. So I think they should be a copy of this diagonal here. So it's going to be some kind of copy of this one. Let's take a photo of it, a little snip. But they are definitely rotating. So what are the rules about rotating? So pointing down, so that's pointing left, pointing down, pointing right. Pointing left, pointing down. So that means if that's pointing left, it's probably going to end up, it looks like it's rotating along these diagonals. Each time it's being rotated, so if we go from here to here, so we ascend, it's rotating anti-clockwise. So what I've done is I've taken my shape here, as I moved it up, I've rotated it anti-clockwise. So that one actually does match A. So I think that's the easiest way to solve this. And are we doing anything else we can see? So yeah, for each, so pointing up, left, left, down. So it does seem as though, yeah, I'm pretty sure that's it. So as you look across the diagonals, you have the same shape, and as you go up the diagonals, they're rotating 90 degrees anti-clockwise. That's my best answer. So sorry, 56, the answer is A for that one. Okay, then now we're on to odd one out. We like the odd one out ones. There's 5 to choose from, so you need to make sure that for each of these there's a good reason for why the others are grouped up. And again, a bit like with the vocabulary, if you can explain or if you can sort of define what makes something a group, you can then be a lot more confident that you've got the odd one out, essentially. So you want to be able to put it into words why they're all a group. It's a good check of what's going on. Okay, well, already I can just sort of jump out to me that that circle has moved. All the others have got the circles near the front of the line, whereas this circle doesn't. So I think D is the odd one out because it's the only one with that circle that's moved. On then to 58. I think this looks like another rotation to me. So if I take one of these, They should all be the same, copy each other except for one of them. So let's have a look. Shrink it down a bit so we can see more easily. So that's that one. That's also C. That's also B. That's also E. But do you know which one it isn't? There's no way to rotate it to be the same as A. You can see how the big one, the little one, have swapped over. So A is actually not a rotation, it's a reflection, whereas all the others are rotations of the same shape, of the same group. Right, looking now then at 59. Well, that's 1 then 2. 3, 4, 1, 2, 3, 4, 5. Okay, 1 then 2, 4 then 8. So are we doubling every time? We're not doubling in C, but we are doubling in D, and we are doubling E. So I think C is your one out, because the rectangle should have twice the circles as the circle has inside them. So 1 to 2, 4 to 8, 3 to 6, and 5 to 10. I think that's the rule that we spotted. 60. So it's a 5-sided shape and a 7-sided shape. It's a 4-sided shape and a 6-sided shape. So are they just 2 more each time? That seems like it could be a pretty good rule. Actually, and is that, no, that's 4-sided and 8-sided. Oh, that messes my rule up. Hang on, counting more accurately. That's 5 and 8. That's 3 and 5. Oh, so maybe right. And that's 5 and 7. And that's 7 and 9. Right. So I think I've discovered it. Maybe accidentally. I think A is the answer because it has 5 sides on the inside and 8 sides on the outside, which is a difference of 3, and all the others have a difference of 2 sides. So I think that's my answer. 61. Well, just looking at the blacks, they are in the same place on all of them, except for D. So the black squares seem almost fixed, except for D, where this little one here has moved. So 62. Right, well, 1 curve, and 3 straight, 3 curves and 1 straight, 2 curves and 2 straight, 3, no, so it's not, it can't be the number of curvy sides, which is a shame. But is it just odds and evens? So you've got 1 curvy, 3 curvy, 2 curvy, 1 curvy, 3 curvy? Let me just think. It's not to do with the right angles, because 2 right angles, no right angles, 1, 2, none. No, so it can't be that. So I think it might just be C, because it's got an even number of curved sides, or an even number of straight sides. This is more an even, but all the others were odds, irrelevant to what you counted actually. Either the curvy ones or the straight sides. So I think that's the best answer, because there's not much else going on in that one. 63. Okay, well they've all got 2 squares, and they're all pointing downwards, so that's a good sign. Do they all have... Well, so that's got no spaces between the squares, but that's got one corner, 1 vertex between. That's got 1 corner. Oh, that's got no corners, and that's got no corners. That was a shame. I thought that was a good idea. So it's not the placement of the corner. That one's got a corner. So yeah, hang on. Square, corner, square, square, corner, square, square, corner, square. Yeah, so no, I take that back. A is the answer, I think, because it doesn't have a vertex or a corner between the squares. And sorry, that one did. I just missed D for a second, but no, it does have one. So yeah, A is the answer. All the rest have a corner between the 2 squares. Right, guys, you're doing really well. We're on to the last section, which is series. Series is really important, a bit like matrices, really popular, comes up an awful lot, almost every year. And it's a bit like a matrices, but even simpler, because you've only got to sort of go in one direction, comparing from left to right or right to left, whichever you think is easier, and looking for sort of the changes. And it seems to me that we are 1, 2, 3, 4, 5, 1, 2, 3, 4, so we want 3 sides, because we're losing a side each time, so it's not that, not that, not that, not that, so it must be B, just based on the number of sides for 64. 1 fewer edge, 1 fewer corner, 1 fewer side, however you count it. 65. Is this another rotation? Look at those lollipops down and right. Yeah, I think it might be. Let's take a snip again. Whenever I'm suspicious of rotations, I like to take a snip, because obviously I know in real life you can rotate your books to do a similar effect. But this one, if I rotate that one anti-clockwise, that seems a pretty good match. If I rotate this one then anti-clockwise, So a very good match. Then going in reverse, this one, and then their answer should be this one, which I think for 65 means it's answer option A. That looks about right to me. And then, yeah, just a way to check, I suppose, is that last one. If you rotate it again, yeah, definitely that one then. So that's my answer. I'll leave that there so you can see. And again, I'd have probably been drawing sort of a sketch of that one. 66. 66 has got one fewer side each time. And it seems to me that the circle is always one away from the gap. So I feel like we should almost have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3. So we should have sort of 2 lines. But then of the 2, it should be this one that has the circle, because if you look, this is always moving up one space. So A is close, but a bit tricky. I actually think C is the better answer, because it's got the right number of sides. None of these have got the right number of sides. But the circle is actually in the right place, or the little white shape is in the correct area there. Right, guys, last page. You're doing really, really well. Thank you so much for your attention. I know it's quite a lot to go through all these. Hopefully you're taking them in and understanding how these work. On then to 67. So, well, whenever I get shapes and just shapes, I like to count things. So that's 6, 6, and 5, which is 17. That's 5, 5, and 5, which is 15. Okay, that could be a pattern. And if that is the pattern, it'll be 17, 15, 13. So this one should add up to 11. And does it? We've got 8 plus 3, 11. Yeah, we absolutely do. Well, this one should be 9, and that is a nonagon. So yeah, I think we're onto something. So we're looking for 13 sides in total here. Well, that's close, but that's 12. That's far too few. 12 again. This looks better. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hang on. 7, 8, 9, 10, 11, 12, 13. Oh yeah, I'm trying to count to 13. That makes sense. So yeah, D is the answer. I wanted to get 13, and I think 13 is D. So that's definitely the answer. Right, 3 questions left. 68. Okay. Well, it looks like the dashed would here. Look, it doesn't. So they got it's on the inside, then the outside, and the middle. So it seems like the dashed line is moving one space over each time. And if we go, it's sort of moving. If we go from the left, it's moving outward. So middle becomes outside, outside becomes middle, very middle becomes center. So it should be this next one, sort of out here. So I think we're looking to see sort of a dotted line like in the position of A. So let's just eliminate the ones that are wrong. So no, no, not B and not C. What else are going on with the grey line? So middle, then outside, going reverse. Outside, then middle, then very outside, then second from the outside. So we now want it to be in third from the outside. Well, that's not third from the outside. But 1, 2, 3. D is third from the outside. And I think it's also got the right dotted place. So I think my answer for 68 is D. Because the dash one's the right place and the grey is the right place. That's pretty good. 69. Okay. Well, the shading seems to be moving to the right. Then it would be in the 3rd position. Then it would be in the 4th position. Then it would be moving back down again. So is it just a case that the thick shading is moving over one space? Yeah. So I'm not sure it's saying so it's gone from here to left. So I think that the thickest one, whatever that shading should be on the right hand side. Now let's actually work out what shading, because it's not the same shape. So it was the yeah, because the shapes are also moving, because the circle has moved over one, the triangle's moved over one. So the shapes are moving to the right, but the shading is moving one to the left. Okay, I think we've got it. So let's draw the shapes first. So to the right, so you're going to have the arrow is going to be in the 2nd position, the circle is going to be in the 3rd position, the triangle will be in the 3rd, and then this one pops off the end, so we've got ourselves, I actually drew the right one, and it's this one, I'll do it in red, this is the one that should have the thick border, because that's the same moving, so let's see which one matches with that. Nearly, in fact no, is that right? Is that A? 69A? Yeah, I think it is, there you go. That was the correct answer. That was quite cool, I like 69, that was a good question. 70. We got 1, 2, 3, 4. 1, 2, 3. So 1, 2, 3, 4 lines, 3 lines. So we go down to 2 lines, then back up to 3. Or 1, 2, 3, 4. 1, 2, 3. Maybe 2 crosses over, 1 cross, no, yeah, okay, so I think they cross over 4 times, 3 times, I'm guessing 2 times, 1 times, no times, because if you look at it, it can't be the number of lines, because the number of lines don't seem to be changing properly. So we want something that crosses over twice, so that is twice, that's twice, but that's only once, that's only once. So that eliminated a few options, and then what's going on with this arrow? So it's top left, top left, bottom right, top right. So yeah, I think we're expecting to have it down here somewhere. Oh, well, look at that. They're all in the right location. Well, fair enough. But then what direction? So it's pointing down, then pointing left, then pointing right, then pointing down. So that's a rotation clockwise. So from here, it would be pointing up, I guess. So down, left, up, right, down. So we pop that in the correct position. I think we want something that looks like this, with 2 intersections, 2 crossing overs, and that's not pointing up, but that one, B, is pointing up. So my answer is going to be B, just based on the arrow. And actually, I think many of those, you could probably have pretty much answered that just based on the arrow being up, because there's only 2 options with the arrow upwards. And that, everybody, is the end of the test. So thank you so much for taking part. We hope the pre-mock was useful. Obviously, any questions, don't hesitate to reach out to your tutor, and you're more than welcome to bring these in and hand them in and show them to your tutors at the end of any sessions if you've got any questions. But also certainly well worth watching this video and going through and trying to make the most of these question types, because they are a pretty good example of the kind of thing you'll be seeing in your real mock exams. Thanks for watching, everyone. All the very best of luck. We'll see you again soon. Bye bye for now.